Here's a list of code review items so that when you approach a code review you can simply scan this code review checklist and see which items you want to follow when doing the code review. So first, logging. Do you have the proper logging in place? You should not have too much logging, especially for operations that happens a lot, but for single time operations or when you want to troubleshoot, you should have the proper logging at a proper level. For that purpose, we have item 2, which is the monitoring, which is much more scalable. So if you have hundreds of servers, you will probably want monitoring or either monitoring above logging, but logging would be a lower case. Scale. When you have added a feature to your code base, you should ask yourself, how would that feature scale with increased load, traceability? Ask yourself, what if some problem happens? Could I trace where this problem originated, which is close but not exact like troubleshooting? With troubleshooting, you should ask yourself, if a problem happens, what are the tools that I provide to me and other developers? It could be documentation or procedures for finding the root cause, reporting. Many times you have in your application reporting. Should this feature affect reporting? If yes, and you didn't handle the reporting, then maybe you want to update the reporting as well. UX. Should this feature affect the UX? Notice that in many times we have coded the features, but we didn't really code everything. So we didn't code the logging, the monitoring, the scale, the traceability, the troubleshooting, the reporting. So a coding task is not only the feature, but it's also the UX maybe. Maybe something should change in the UI and you didn't notice it. Incorrect problem definition. Maybe this should be item number 1. Is this feature solving the real problem, or is it solving only what was presented in the task? These are two separate things. Time management. By the way, when we do the code review, how much time did it take to code it, or how much time is left? Is it as we appreciated it to be in the original task estimation? This is going to be very interesting to see in code review and why this happened. Ignoring other features. Maybe someone is already coding the exact feature. You should take care of it. Or maybe this feature is affecting another feature. So it's time to raise this question when we do the code review, or even before, but also in the code review. Is this feature affecting other features that we have ignored? Focusing on today's needs. This might be a correct way to do a task, to focus on what is required now, assuming you have added to the backlog the future needs. But in many times we are sacrificing the future for today, so we are taking like a loan. But still, you should check if maybe we focus too much on today's needs and not on the future. Alerting and metrics. If something bad happens that we want to be alerted about, then raise an alert. And the alert should not be on one error, it should be on an aggregation of error usually, in many cases. Not always, but in many cases. Testing. Did we do the proper testing? The proper testing means not too much testing and not too little. Usually it's better to have component tests. And for component tests, we want to test like the most end-to-end feature testing, which is not an integration test, so that you can run it as part of the UI tests and not as the global integration test. So in this episode I'm just scanning everything. If you want me to elaborate on something, just give me a comment. Deployment. Is this affecting deployment, and did we take the proper measurement for affecting the deployment? For example, when we deploy, how do we test it? How do we know that it actually worked? So this could be something that should be added to the code. The code cleanup. Of course, when we say code review, the immediate thing that comes to mind is code cleanup. But it's also very important to, I think the most important thing is the naming of stuff and how easy it would be for other people to manage and handle this code, because if we just made it more complex, not sure it's the right way. Latency. Did we do something that increases the latency by much? We should take care of it. For example, regular expressions and stuff like this. Was there a proper design review on the feature? Because if not, we might have coded that something that we should rewrite. Was there a customer review? Did any customer check it? Concurrency. Did we do any extreme concurrency, or maybe we also introduced concurrency bugs? So if there is any concurrency in the code, or it's related to any concurrency, or it should be concurrent and it's not, then you should take care of it. Simple bugs like ifs and stuff, did you handle the cases and stuff like this. Mutation. If you're doing mutation to variables, you should check if you could use immutability, which would help in general both to understand the program and also to handle concurrency. Readability, of course, if the code is readable. Naming, where they mention. Documentation. I think the most important thing is to say the motivation for the feature and the motivation for this design, because many times when you look at stuff and code and features, you see them, but the thing that would most help you is to understand the motivation, what caused you to name this feature like this. Audit. And many times you want to know the series of operations. So if you added a feature that adds permission to a user and this is the feature, then maybe you want to audit and to have like a list of this guy has used this feature, this guy has added a permission, this guy has removed the permission. Security. If you're dealing with the entry points like the web services, the REST endpoints, you should take care of security, you should validate stuff. If you have a complex if then logic, then you should think if it could be simpler. If you're breaking for a loop, this is some smell that you should think whether it should be the right case. Negative logic. If you do if and then not some condition, this means that you don't have the right naming in your code and you should prefer positive logic in general, not always. If you introduce some new regex or updating some existing regular expression, this could cause some issues. You should check it maybe on large scale inputs. Nulls. Do you have nulls in the code? What happens if you have nulls in the code? More than 3 arguments. Usually when you have something with more than 3 arguments, this means that the body of the SHA function is doing too many things. When it's doing too many things, it's time to rethink that piece of code. Also line length. If the line is too long, I'm not saying 80 characters, maybe 150 characters. If it's longer than this, then maybe you're doing too much and it's too complex to handle it. You will notice that when you compact the line length, some other things will pop up, which will make the whole feature, you could even redesign the feature when you reduce a line. This happened to me. Shared resources and abuse. Let's say you have one variable or one global state, like all the users of the system, and you access it for multiple points. This should be handled with care. If you introduce a cache to make your server maybe react faster, what is the trade-off? Did you think really about the trade-off? What if the underlying data changes? How that cache invalidates? Check if your variable names are too long. The commit message should be, I usually take care that there is first single line which is not too long, not too short, and describes it, so that when you do git log with -1 line, you will see concise log messages. Squash if needed. If you had like 20 commits or 5 commits, then when you do the final push or commit, maybe you should squash it so you can revert it easily. Build time changes. notice that if you add tests and stuff like this, if you increase the time to build a project by 5 minutes or something like this, it's not good. Check if you could not increase the build time. If you use the random, new random and then random نقطة dot next int, this is some usage smell. At least use some seed so you can reproduce it. The open close principle, of course, is that you should check that if you are especially designing API, then it's open for additions and it's closed for changes so that you can be backward compatible. Code duplication. Do you see any code duplication? This is also a hint that something is going wrong. Over complexity. For example, you use type when a simple string is enough. Under complexity, for example, you use a string when you require a type, for example, username or email address, or I mean the user. What is a user? Is it a username? Is it email? So types are required. If when something fails, multiple tests fail, this also may mean that you have over-managed a test. Backward compatibility and forward compatibility, note this as well. In API, see if you have versioning. In databases, see that you use relational database when required and you use unrelational NoSQL when required, and maybe you need even a search engine so you could have your main data in the relational or in the non-relational, but if you need a search, then maybe you need a duplication of the data into Elasticsearch and you do search from there. Sometimes you might fall into the pitfall of adding an index instead of duplicating the data into a search engine, because an index adds overhead. Ignoring failures. Did you think about failures? So this does not mean that every operation and every piece of code you need do should handle failures. All this means is that you should have a clear failure handling and you should know how you handle the failure. I usually like it when there is a single failure handling and I don't mess with failures. I just have like one global thing. I don't call this global thing. Just let the code fail, throw its exception and catch it in a global thing. This is easy enough and in most cases it works well. Expecting the feature should work. You should expect the feature not to work and think what you should do about it. Two verbose error handling, I mentioned it. Sensitive info in logs. Did you log passwords and stuff like this? Log credit cards? Big no. Missing main flow. I think maybe this one is one of the most important, maybe even the first. You should have a clear flow in your code, like a main function, so that when someone looks at your code, it understands what you're doing. Like step 1, I'm doing this. Step 2, I'm doing this. Step 3. This is the perfect code in my mind. You look at the code and you understand the steps. So if instead of that you have a function that calls a function that calls a function that calls a function, you don't really understand what's happening. It's of course it's okay to call multiple functions, but you should have some kind of a main flow. Feature toggle. In many cases, if this is risky operation, you want a feature toggle, or if you want to test stuff. Dependencies. Did you add new dependencies? If yes, check if there are collisions that you should resolve. Usually I don't have any comments, really. I don't have any comments in the code. I try to have the method names, the function name, the variable name, the main flow that we just described, to describe it all. But if you have a command, then think about it. Because in many cases this is a smell that something is not good in the code. Dependent teams. Did you affect any dependencies? Because if yes, you should send them a notification. Plural, singular, correctness. Check in your API if it's clear for the user, or in the function if it's clear for the user of whether you're doing with one item or multiple items. Consistency with code-based conventions. Of course, having said all the above, you should also look at your surrounding, the code surrounds you, and see that you are consistent with the other code base. Revert. What would happen if you need to revert the code? Of course, if you squashed it, for example, it would be very easy, but are other teams and modules dependent on you? think about it. In many cases, I like to have a simple return from a function, or if I have multiple return commands from a function, then I try the flow to be very simple. But if you have a complex flow in a function with multi returns, then think about it. And how much time did it take you to do the code review? How much time did it take you to understand the code? If it's taking too much time to understand something, this is a hint and a smell that you should fix it. So if you have any questions or want me to elaborate on any of the above, which is the code review checklist, brain backup export, please let me know. Thank you and have a good weekend.